Hello everyone, let's learn about Ramachandran plot. In CSIR examination point of view, this area is very important. Once you understand the concept, you can solve any problems from this area. Most of the protein is consist of alpha helix and beta turns and connected by turns or coils in order to avoid the clashes between the atoms, right? So, two atoms cannot occupy in the same space. That is a basic principle behind the Ramachandran plot. What is the Ramachandran plot actually? Actually, it is the way to visualize dihedral angles psi and phi of an amino acid residue in a protein structure. It is the way by which we could identify the secondary structure of protein depending upon the rotation or degree of freedom of dihedral angle psi and phi. The secondary structure of the protein could be alpha helix, beta sheets or loop structures. Let's look at the characteristics of Ramachandran plot. First of all, it consists of 4 quadrants. You can see that 1, 2, 3, 4 quadrants are there. In the y-axis, you can see that minus 180 to 0, 0 to plus 180. Y-axis will be psi angle. In the x-axis, you can see minus 180 to 0 and 0 to plus 180. And the x-axis will be phi angle. The third point is that a definite position in the plot will indicate the definite secondary structure of the protein, and the plot contains both allowed and disallowed region. Let's look what is that. Before entering to our topic, let's look how a peptide bond is forming. From this figure, you can clearly understand that the formation of a peptide bond between the two amino acids by the process of dehydrolysis reaction. Let's look what is torsion angles, that is phi angle and psi angle. In this structure, oxygen is more electronegative than carbon. So, electron pair towards the oxygen and the carbon become more positive. As a result of this, what will happen is that nitrogen create a partial double bond. That is the CN bond, the peptide bond is partially double bonded condition. So it is so rigid. That means the free rotation is not possible here. The angle between the C alpha and N is a called phi angle. The angle between the C alpha and C carbon is a called psi angle. Both of the torsion angles are free to rotate. While the peptide bond, that is CN bond, it is partially double bonded condition, so it's so rigid. So free rotation is not possible here. Only the torsion angles, that is psi angle and phi angle, are free to rotate. So the shape of a peptide chain can be defined by 3 constitutive bond torsion angles, that is C alpha N and C alpha C and CN bonds. I'm already told you that is C alpha N, it is also called phi angle, it is free to rotate, and C alpha C is also known as psi angle, it is also free to rotate, while our CN, that is our peptide bond, is rigid planar due to its partially double bonded condition, so it is the free rotation is not possible here. Two conformation are possible for planar peptide bonds, that is trans and cis forms. The trans is most preferred because the distance between the molecule are very high in trans conformation, so that the chances for the clashes between the atoms are very less. That means the steric hindrance is very less in trans form, while in cis forms molecular distance between the molecules are very less, so the chances for the clashes are very high. So the most preferred form is the trans form. In computing a Ramachandran plot, atoms are treated as a hard sphere where dimension corresponding to their van der Waals are ready. Any angle that results into collision of sphere are regarding as sterically unfavorable, and hence such conformations are not allowed. The 3 regions in Ramachandran plots are the most allowed regions, and disallowed regions. In this figure, the red color regions are the most allowed regions, and the yellow colored regions are the allowed regions, and the white colored regions are the disallowed regions. In the first quadrant, anti-parallel beta sheets, parallel beta sheets, and right twisted beta sheets are commonly seen. In the second quadrant, the left-handed alpha helix are commonly seen, and the third quadrant, right-handed alpha helix are commonly seen. Glycine and proline, both of these amino acids have no preference in Ramachandran plot because of the small size of glycine, it show maximum allowed conformation in Ramachandran plot, while proline it show very least allowed conformation because proline has a cyclic side chain, so rotation around the bond is constrained by its inclusion in the pyrrole ring. So the 5 value are restricted to angle around a -16, and hence the proline is the most conformationally restricted amino acid in a Ramachandran plot. Try to memorize the values of psi angle and phi angle in 4 corners. That's why you can simply answer the questions from these regions. I hope this video helped you. If you like this video, please hit the like button and post your valuable comments also.